Alright, this video is going to look at geometry. And that's kind of skirting the edge of the definition. But we're going to look at how to calculate area of different shapes, the slope of different lines, and how to determine missing angles. So really, we're going to be looking at shapes. Alright, let's get started. How to find the area of a graph or a shape. Okay, a graph is basically just a bunch of lines that make up some sort of shape. You're going to break the shape down into recognizable pieces. So for example, with this graph below, this right here is a triangle. Okay, and then I have a square right here, or a rectangle, excuse me, and then I have two more triangles. Okay, so I broke it down into recognizable pieces. When you're finding the total area, you add your area together. So it would be this plus this plus this plus this. And you're going to keep positive and negative in mind, which means this right here, the shape, because it's below the axis, will be a negative number. All right, let's get started. All right, the area of a square or rectangle. The area of a square or rectangle will be found in your reference table, and I also put it right there. It's base times height. Okay, so when we find that rectangle, that was right here. Okay, now the base is how big our base is. So we went from 3 to 6. So our base is 3, and our height is 0 to 1. So our height is 1. So the area of the triangle, or sorry, rectangle, is 3 times 1. That's 3. Okay? Now, area of a triangle. Whenever we're finding the area of a triangle, we do 1/2 base times height. Okay? So, if I start with this first triangle, I'm going to do 1/2 times the base. Now, the base is the widest part. So, in this case, the widest part is about, let's go with 2.5. So, 1/2 times 2.5 times height, and the height is the tallest part. Okay, this right here went to -2. And that negative helps us keep in mind and remember that this part's going to be a negative. So it's 1/2, 2.5 times -2, which is -2.5. That's the area of triangle 1. Now, area of triangle 2 is equal to 1/2 the base. So if this was 2.5 and this is 3, then my base is 0.5 times my height, which was 1. Okay, so that's going to equal 0.25. Okay, the area, let's do it in a different color. The area of triangle 3, and that triangle 3 is this one, okay, is equal to 1/2 the base. The base is 6 to 7, so the base is 1. The height is also 1. So the area of triangle 3 is 0.5. Okay, so found the area of each of the pieces. Now to take the total area, you add them together, and you keep positive and negative in mind. So the rectangle was 3, plus the first big triangle was -2.5, plus the first small triangle, which was 0.25, plus the third triangle, which was 0.5. And we take this and we add it together. We keep that negative in mind. So this and this is 0.5, plus 0.25 is 0.75, plus 0.5. That is equal to 1.25. And that's the area under the graph. And that has meaning. We're going to learn the meaning during class. But now you know how to do it. So now that you know how to do it, all you got to do is concentrate on the meaning. The other shape that we care about area for is the area of a circle. We also care about the circumference, which is the distance around the circle. Okay, and both those are given to you on your reference table, and they'll look like that. Okay, now the only thing that's not given to you is that the diameter is twice the radius, so the radius is half the diameter. But I'm pretty sure most of you guys know that. Okay, now I'm not going to fill in this whole table, but I will fill in this first row, just so you can see us working. If the radius is 6.5, the diameter is twice the radius. So that is 2 times 6.5, which is equal to 13. Okay? The circumference, capital C, is 2 pi r. And I'm just going to use 3.14 for my pi. If you want to do more digits in your calculator, that is fine. Okay, so that's 2 times 3.14 times 6.5. 2 pi r. And that gives us a circumference of 40.82. So that's how big around the circle is. Area is equal to pi r squared. So that's 3.14 times 6.5. All right, so 3.14 times 6.5 squared is equal to 132.665. Okay? That's the area of a circle, or of this particular circle. Okay? I'm sure you've all calculated areas before, and you've also calculated slope before. We're going to go over it again because both area and slope are hugely important because they mean things in physics. They're not just numbers. They have meaning. Okay? When you're doing a slope, if it's a graph like this, you're going to have to break it into segments. Just like you broke it into shapes, you're going to have to break it into segments. So we have 0 to 2 minutes, or seconds, excuse me. We have 2 to 3, 3 to 6, and 6 to 7. Okay? So when the slope changes, you get to start all over again. So if I want to know the slope of the line from 0 to 2 seconds, slope is change in y over change in x. Y is your up and down axis, x is your across axis. Now change is final minus initial. All right, so final y minus initial y divided by change in x. So final x minus initial x. So for 0 to 2, it finally ends at -2. It started at 0. Okay, 0, -2. X ended at 2 and started at 0. So that becomes -2 over 2. So the slope of my line is equal to -1. Okay? If I was to do this for 2 to 3 seconds, all right, at 3 seconds, at my final spot, it is at 1. So final is 1. Initial started at -2. So final minus initial. So that's minus -2. Divided by final time. That would be 3. Or final x. In this case, x is time. Minus initial, which was 2. All right. So 1 minus -2. That's 3. Divided by 1. Okay, slope of the line is 3. Now from 3 to 6, final position. It ended at 1. All right, let's do that in a different color. It ended at 1. It started at 1. So it's 1 minus 1. So I can already tell you it's 0. My change in time was from 6 to 3. So that would be 6 minus 3. So that's 0 over 3, which equals 0. So the slope of a flat line is 0. The slope of a line heading up is positive, and the slope of a line heading down is negative. Okay? I'm not going to do the third one. If we did number 1, or the first section, you can do the second. All right, last thing, missing angles. A couple of conventions and things that you need to know that are always true. 1, if 2 lines are perpendicular, that means they have an angle of 90 degrees. So perpendicular means basically this and this. These 2 lines are perpendicular. These 2 lines are perpendicular. Okay. Sometimes they're labeled with a little X in them. Okay. So they don't have to necessarily be shaped like that. They could be shaped like that. Those 2 lines are still perpendicular, no matter what we do. Whee! Okay. Sorry, that was fun. All right, straight line. Straight lines are 180. So if I have a straight line, here to here, it's 180 degrees. Okay? And here to here is 90. If I have a full circle is 360 degrees. All triangles, all the angles of 3 triangles add up to be 180. And that's particularly powerful if you have right triangles that look like this, where this one is 90. Okay, right triangle. If you know this one, let's say that one is 40, that means this one needs to be 50. And squares and rectangles, the 4 angles together add up to 360. All right, so straight lines and triangles have the same. Full circles and squares have the same. Helps us when we're finding missing angles. The other thing, this is called a transversal diagram. You've probably seen it. We won't do a lot with it, but it helps us look at relationships. All right, so let's say number 2 was 50 degrees. Okay, this whole thing is 180, which means this must be 130, because the 2 added together have to equal 180. Same with this one. All right, so that has to be 130. Well, that just shows us that this angle and this angle are equal. Okay? Now down here, we get the same relationship. This big angle here is actually the same as this big angle here. Now, so that's 130, which means that's 130, which means that's 50, and that's 50. Okay, so opposite intersecting angles are equal, and corresponding angles are equal. So corresponding are these 2, and then opposite intersecting are these 2. Okay, that'll help you interpret things that you see. For example, with this one. All right, opposite intersecting angles are equal, which means if this one is 25, that means this one has to be 25. This is a straight line. So that whole thing is 180. So I have 100, I have 25, and something is going to equal 180. Okay? So that would be 55. Okay? Over here, if this is 110 and a straight line has to be 180, that means that this is 70. Now, we didn't ask for it, but we could also find this angle of a triangle, because 70 plus 55 equals 125, okay? And if a triangle has 180 altogether, that means that remaining angle is 55. Okay? Now, this big triangle doesn't have much practical use, but if you get something complicated like that, the simple ones that I'm going to give you, they're going to be easy peasy. All right. Hopefully in this video, you learned how to calculate the area of different shapes, the slope, and how to determine missing angles. Good luck.